Hi, Mr. Reeves. Your audio is really high. I don't know if that maybe that's mine. I can't understand what you're saying. I'm gonna try rejoining it.
Hello, my name is
Hello.
Mr. Reeves. I got Paul joining us. Hey, Paul, how you doing, buddy?
I'm good. How are you?
Good.
Mr. Reeves?
Yeah.
Is there a packet that we should have printed out for today?
I feel like I gave you the chapter 11 packet a while ago. We've been working in it for a while. Do you not have that?
I've been printing them out by individual days.
Okay, that's kind of, you can print them out by individual days. You can go ahead if you like and print out more of them, but that's kind of where we are.
Do you know what day we're on today?
We should be on 5.6 day 2.
Thank you.
That is actually what I am currently looking for. There's 5.5 day 1, which we've already done. 5.5 day 2. 5.6 day 1, I'm getting warmer, and 5.6 day 2. Okay, so here we are. It should look something, switch cameras, something like that. No, nope, that didn't work. How about this? All right. Oops. 1 sec here. I'm gonna add an extra camera, just because you can't get enough Mr. Reeves. Anyone? No. I think that is agreement then. So we are meeting number 4283. Enter, and you should get a second history.
This meeting is being recorded.
Sorry. All right. All sound good? Look okay? All right, this is us. We should be on 5.6 day 2. I'm just going to pin this video so I can see it a little bit more clearly. Focus button, and that made everything much worse. There we go. Okay, so here we are. Does this look familiar? Oh, yeah, I'm for some reason upside down. That's very strange. It's my camera is upside down. Okay, there we go. So you can see my stuff. You can see a picture of me if you care to. We are on 5.6 day 2. It's just kind of where things left off before the break. Still in the midst of this section on logs, which spans 2 chapters. Let me do a little quick count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm recording this for Darcy, but I feel like we should have one more person.
Aaron's trying to get on right now, I think.
Aaron's trying to get on. Okay. Oh, she's right there. Did she just emerge? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now Aaron's on. I have both of my Owens. I see Darcy. Who are we missing? Oh well, I'll take attendance in a little bit and we'll figure it out. Okay, looking at this problem right in front of us, can you guys read it? Do you have it in front of you? We all good? Okay. Somebody's got some classical music or something playing in the background. Brandon's with us now. Okay, perfect.
Mr. Reeves,
Yes.
can I just double check with you that this packet that's titled Properties of Logarithms, is that the first one?
I'm looking at Unit 10, Section 5.6, Day 2.
I know, but the packet before this one, would it be Section 5.5, Day
It
1?
would be 5.6, Day 1.
Oh, okay.
Okay, so as a general rule, anytime my variable is in the exponent, in order to get it down, I am going to take the log of both sides. And because I myself am a mathematician, I'm going to take the natural log of both sides. Now, generally speaking, I would not write this step. 2x minus 3 equals the natural log of 5 to the 4 minus x. The reason that I would not write that step is if you knew to do that step, you presumably knew why we were doing that step. And that is that in a log, be it natural log, common log, log base 72 1/3, the exponent can come down. So this is really 2x minus 3 times the natural log of 5 equals 4 minus x, also times the natural log of 5. At this stage, the natural log of 5 could go away, but perhaps if you look at this particular equation, not the next one, not this one, not number 4, but in this particular one where they had the same base, I could have jumped straight to 2x minus 3 equals 4 minus x. If 5 to some power equals 5 to another power, then those two things are equal. Here we've actually done it algebraically, as opposed to just saying, oh yeah, that makes some sense. So that was the algebraic steps. So what I'm going to do from here is I'm going to add x to both sides. I'll get 3x. I'll add 3 to both sides equals 7. And I will get that x equals 7/3. And that looks good to me. I'll put a box around it. Okay. Number 2, I'm going to be a little bit sneaky here. Yes, I have a variable in the exponent, but if I take the natural log of both sides, it's going to be ugly. How does 7 to the log base 7 of 2x reduce?
Is it just 2x?
X, yeah.
Just 2x. Yeah, that was one of our rules of logs, that if I have a to the log base a of x, it's just x. Subtracting x from both sides, I'll end up with a single x over here equals 5. And I think I'm done. So I'm going to put a box around it. Okay. Number 3, there is a obvious base which I'm going to take. It's the base which I like to take anyway. If you took any other base than the natural log here, it would be really silly. For the last time, I'm going to write out this extra step. And the whole point is that I get 2x minus 1 as a coefficient instead of an exponent. And wait a second, what is the natural log of e? I think I heard Daphne or saw Daphne mouth the word.
Oh yeah,
Is it
sorry. 1.
1, absolutely. I thought I saw that in there. The natural log of e is 1. Really, the question that natural log of e is asking is e to what power equals e?
Miss Class.
The first equals e. So now I have 2x minus 1 equals the natural log of 3. How about 2x equals the natural log of 3 plus 1? And x equals the natural log of 3 plus 1, all divided by 2. Sound okay?
Yeah, thank you.
Okay, in this case, I am definitely going to have to take a log of both sides. Again, I like to take the natural log of both sides. I'm gonna write natural log of 10. Where is the 9x gonna go?
On the outside.
Coefficient, I heard. Yeah, I love it. In front of it. Equals x minus 3 times the natural log of 3. The natural log of 10 and the natural log of 3 are just numbers. Don't be like afraid of them or shocked by them or anything like that. Nice. And so I'm just going to solve for x in a normal way. It's a little convoluted here. I really have x times 9 times the natural log of 10 equals x times the natural log of 3 minus 3 times the natural log of 3. I'm going to move everything with an x to one side. 9 times the natural log of 10 minus x times the natural log of 3 equals negative 3 times the natural log of 3. And then I'm going to divide out an x.
Can you move down, please?
Yeah.
Yep.
What's the reason that you were able to take the x out of both sides?
I factored it out.
But like, how does an x come out of natural log of 3 on the opposite side?
How does an x come out of natural log of 3? It said x minus 3 times the natural log of 3. So I multiplied it. I distributed natural log of 3 into x and into negative 3. And I just subtracted this over to this side.
Wait, how did you get x natural log of 3 minus 3 natural log of 3? That's just where I'm really confused.
Minus right here.
Mm-hmm.
I distributed. Right. I multiplied that by that. That's my x times natural log of 3. And I multiplied this by that. That's my minus 3 times the natural log of 3.
Okay.
And there is an answer. I can make it look a little bit nicer, but for the time being, we're going to leave it like that. And that is what I would call an exact number. If you plug it into a calculator, you're not going to end up with an exact number again. All right, we've got a couple more of these. I'm going to take attendance. I will give you guys a moment or two to sneak on ahead of me.
Mr. Reeves, can you flip over to the last page again, just so I could finish copying down the problem? Thank you.
No problem. they were. So I'm hoping we got an x natural log of 3 equals 2x minus 1 times the natural log of 5. X ln 3, I'm doing the same thing. I'm doing this distribution, equals 2x natural log of 5 minus natural log of 5. X ln 3 minus 2x ln 5 equals negative ln of 5. X equals negative ln of 5 over ln of 3 minus 2 ln of 5.
Mr. Reeves, can you explain your second step, please?
From here to there,
Yeah.
all I did was I distributed. 2x minus 1 is being multiplied by natural log of 5. So I multiplied 2x by natural log of 5 and negative 1 times natural log of 5.
If you're subtracting 2x times ln of 5, then how are you able to divide that if it was just subtracted?
Okay, because there's kind of an intermediate step in here where I factor out that x. So notice this term and that term have an x. So it's x times, well, when I take an x out, I'm left with a natural log of 3. When I take an x out of here, I'm left with a negative 2 natural log of 5 equals that negative ln of 5.
Can you move it down, please? Thank you.
And then I just divide everything which isn't x to get back to there.
Mr. Reeves,
Yes.
if I email you after class, would you be willing to send me a picture of the finished day 1 packet?
Day 1 packet? If I can find it, I've probably tossed it, so I might have to do some work to get that.
Okay.
I end up going through a lot of paperwork over here doing this. Okay, same idea over here. I'm going to write 3 minus x times the natural log of 2 equals 2x plus 5 times the natural log of 6. 3 ln 2 minus x ln 2 equals 2x ln of 6 plus 5 ln of 6. Everything with an x I want on my left-hand side. Everything without an x I want on my right-hand side. So this is really going to be a negative x ln 2 minus 2x ln 6 equals
Reeves, can you scoot it over a little?
ln 6. Yep. Minus 3 ln 2. I'll factor out an x to kind of do that last step. Negative ln 2 minus 2 ln of 6 equals 5 ln of 6 minus 3 ln of 2. As a final-ish step, I'm going to write x equals 5 ln of 6 minus 3 ln of 2 over everything which isn't x over here, negative ln of 2 minus 2 ln of 6.
Mr. Reeves,
Yes?
could you just explain the step between the second and third line?
Between
What did you do
here
there?
and here,
Yeah, what did you do?
I moved everything with an x to my left-hand side. So
Okay.
this stayed on my left-hand side, and that moved over to my left-hand side. And everything without an x, like this guy and that guy, I moved it to my right-hand side.
Gotcha. Okay, I see that. Thank you.
Okay, this time I'm going to go an extra step here. I'm going to do it in 2 steps, although it's really just 1. So bear with me for 1 second. X equals ln of 6 to the 5th minus ln of 2 cubed over the natural log of 2 to the negative 1 plus the natural log of 36. Oh, 1 over 36, excuse me. I'll write 36 to the negative 1.
Wait, if you like multiplied out the last one, why didn't you do that for the other ones?
Because I didn't want to add too much to every single problem. I'm just doing it for this last one.
No, the other numbers in the problem, like 2 to the 5th and stuff.
Why would I be taking 2 to the 5th?
I mean, sorry, 6 to the 5th.
Why would I be taking 6 to the 5th? I did 6 to the 5th.
Yeah, but how?
What is
yeah,
6 to the 5th?
like
Yeah, me neither. So, where I do know what 6 squared is.
okay.
Couldn't you also couldn't you do 2 to the negative 3rd too? Is that okay?
Yes. I'm going to do natural log of 6 to the 5th over 2 to the 3rd over the natural log of, looks like 1 over 72.
What does the, like, putting the exponents, what does that do to, like, change the equation?
It's called compressing it. It's just making it into a shorter equation. Okay. Just reminding us of some of the things that we learned and were doing before the break.
Hey, Mr. Reeves, can you move it down a little bit?
Would it be wrong if you didn't do that part?
It all depends on how they ask the question. So in this particular case, where it says find the exact solution first, I'd accept either one, and then approximate to 3 decimal places. You're going to end up plugging into your calculator either way.
How are you able to put natural log of 6 to the 5th over 2 to the negative 3rd?
What's the rule when you subtract logs?
Oh, it's division.
You divide their arguments, yeah. Okay. Number 7, let's be a little sneaky here. I'm going to write off to the side that A equals 2 to the x. Huh. This looks like 3a squared to me. Minus 11a minus 4 equals 0. And all of a sudden, this problem is starting to look quadratic. How about a 3a plus 1 and an a minus 4? How about a equals negative 1/3 or a equals positive 4? That is saying that 2 to the x equals negative 1/3 or 2 to the x equals 4. If 2 to the x equals negative 1/3, what's my answer?
No
If 2
solution.
to the x equals negative 1/3, what's my answer?
Does that not work?
It doesn't work. 2 to nothing will be negative, but if 2 to the x equals 4, my answer is x equals
2.
2.
So if the exponent is negative, I mean, if the answer is negative, the exponent is no solution.
Yes. This looks a little bit on the similar side. What do you suppose I'm going to make A equal to?
4 to the x.
Great. Okay. And all of a sudden from here, I don't know off the top of my head what the answer is. I'm going to have to use some natural logs. Number 9 looks a little bit differently, looks a little different until I rewrite 9 as 3 squared. And then does it feel like the same thing? Alejandro, was that a question? I saw your hand for a second.
Yeah, why did you cross out the a plus 4?
If a plus 4 were equal to 0, then what would a equal?
A negative number? Okay, gotcha.
A negative number, yeah. So I'm just streamlining that process a teeny bit as we go. Not too bad, not too rough, not too shabby, huh? We just finished what we needed to cover today. Let's take a couple of minutes. We'll still try to get out of here on the earlier side, but let's take a couple of minutes and try to review some of those rules and laws for logarithms and exponents. Sound okay? Mm-hmm. Okay. So first of all, if I were to write the log base b of x equals y, what is that equivalent to without writing the word log or log at all?
B to the y.
B to the
equals x.
Absolutely. Okay, so that's a super important thing. What is the domain of the log base b of x?
X is to be greater than 1.
Greater than 0?
Greater than 0, yeah. 0 to infinity. Can't be 0, has to be greater than 0, has to be a positive number, because really we're saying, okay, b to the y equals x. Well, you can't get a negative or even 0 out of that equation. What about the range of this thing?
All real numbers.
All real numbers. Okay. What is the log base b of 1?
0.
It's always 0. What is the log base b of b to the a?
A.
It's always a. This is asking the question and saying b to what power is equal to b to the a? Oh, b to the a power is equal to b to the a. A couple things that we saw briefly today. The log base b of x plus the log base b of y is equal to?
Log base b of x log base b of x times y.
Yeah. And what feels to be the same thing, the log base b of x minus the log base b of y is equal to?
Log base b of x divided by y.
Of x over y. Love it. And a highly related one, the log base b of x to the a is equal to? And we did a fair amount of that. Admittedly, instead of a random base, we used the specific base of base e called the natural log, but same principle applied. One last one. Another way of writing the log base b of a would be the log base x of a over that's my change of base formula. So for example, if on the test, quiz, final, midterm, whatever, I asked you for an exact value of the log base 7 of 10, what would you tell me is an exact answer?
Is it log 10? Oh wait, no, I don't know.
Like the log 10?
Log 10 divided by log 7.
Sure. The common log of 10 over the common log of 7. Or if you went to plug that into your calculator and found that your common log key was broken, what could you do instead?
Natural log.
Natural log of 10 over the natural log of 7. Now, I like the first one as a rare instance where I like something that isn't the natural log, because I know what the common log of 10 is. What is it?
Oh.
It's just 1. They're saying 10 to what power equals 10? No, 10 to the first. Yeah, Alejandro, what's up?
I remember you got over this, but I can't remember how you did it. How do you get log base 7 of 10 to log 10 over log 7?
That is the rule. That is this rule right here. The log base b of a, whatever b happens to be, is log base whatever number you choose of a over the log base same number that you chose before of b. So the base that we chose here was 10. And we can show that if you want. So if someone gave me this, just for the fun of it, if someone said, hey, Mr. Reeves, what is the log base 7 of 10? But you're not allowed to use the change of base formula. You can derive it, but you can't use it. I'd say, I don't know what it is. I'd call it x. Well, writing that down is the same thing as saying 7 to the x equals 10. If someone gave me this problem, 7 to the x equals 10, I would have said, oh, well, the variables in the exponent, I'm going to take a log of both sides. Because I am a mathematician, I'm going to take the natural log of both sides. So I'm going to say the natural log of 7 to the x equals the natural log of 10. Now, chances are slim that I would have written that step. I'm going to cross it out lightly, not that it's wrong or anything. What would I have written instead?
X natural
And
log
X
7.
as the coefficient.
Yep. Which is the whole point of taking the natural log of both sides. It's that that exponent can become a coefficient. From here, all I have to do is say, oh, x equals the natural log of 10 over the natural log of 7. And in a parallel universe where nobody said I wasn't allowed to use the change of base formula, look what I ended up writing. Natural log of 10 over the natural log of 7. Sound okay? Okay. Well, we are back in it again tomorrow. I will send out some updated homework for you guys, and I will see you here then. All good?
Thank you.
You bet. Have a good one, guys. Bye, 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 bye.
Mr. Reeves, I
Bye.
still haven't gotten back my test.
Okay, you don't really get them back, but I can let you know how you did. I'll send you an email.
Okay, thank you.
Let me do that right now.
Bye.
Have a good one.
You too.
And Owen, are you there? Okay, I'm just going to end the meeting. Leave meeting.